Good evening. So here's a heavy duty topic. So this is homework 7, so it's graphing exponential functions. I promise I will get a producer and these videos will someday be a little more interesting. I'm going to try to be really slow when I move my silly phone. But what we're supposed to do here is we're classifying, so it's classifying each function as growth or decay. So if you attended class today, we did go over a couple of things one thing that's very important is that we have our exponential form, an exponential function form, which is, I will write it right here, y equals a times b to the x, okay? So this is a very important form. You can call it a formula if you want, but it's really more a form that when you see this in math and you see that that there is a variable for an exponent, you know that this is an exponential function. So some interesting things are actually going to happen if we start to, first of all, identify the form. When I look down here, I do see that form here. I see that the exponent right here is really small, but that is still a variable, okay? This b right here that is being raised to that power, there's something pretty special about that. So I'm gonna maybe write some little tips right here. If b is greater than 1, then we know that this is going to be a exponential growth function, okay? Now, the opposite is true. So if b is less than 1, I think you can probably figure out. If this number is less than 1, then we are going to start a decay process, a decay for the function, meaning it's going to go down. It's going to get exponentially lower. So again, for number 1, we are going to classify this. So hopefully you can determine what your b is here. So here's my b, it's a fraction. So my b here is a quarter. That will already tell me that I know any fraction. So if this number is a fraction, then that tells me that I have a decay, exponential decay. So when I start to graph something like that, it's going to be something that starts off pretty high and then it's going to exponentially kind of drop off pretty drastically. If I look over here, I'm going to identify my b, which is 7/2. What's interesting about this is that it's an improper fraction, but this is still, because it's improper, considered more than 1. So b is more than 1. And I'm going to do my arrow here, which means that this is going to be a function that's going to grow a lot. Number 3, I look here. Oh, this might be tricky because you have a fraction here, but that is not in our b. It's not attached to our exponent, if you think about it that way. This is still our b, so our 5, right, is b. A is actually a third, so we're going to grow here too. So that was it's designed to trick you. So then if I zoom out a little bit, so we're doing some graphing here. I think I'm probably going to do maybe the first page. We'll see how far I get tonight. That we're supposed to graph each function using a table of values. And then we're going to identify the characteristics over here. This is going to take a little bit of work and thinking. So the first thing we're going to do here, you have probably in the past seen something like this, is we're going to set up a function table, okay? Because we are going to we're going to create our own values for x, and we're going to put it through the machine, and then we're going to come up hopefully with one y output. We'll see what happens though. So if I start with -2, so this is always kind of a great way to come up with values, right? You got some negatives, you got zeros, you're going to go up to 2. I sometimes like to go beyond just to see if anything more drastic is going to happen, especially with exponential functions. So now I'm actually going to create a little space here just to show my work. I can even label this my work. I like to show my work, okay? The other thing I like to do when I'm trying to create a function table here is I like to start with 0 because I think that anything to 0 power is pretty awesome. So I'm going to do my work here. So in essence, what I'm doing is I'm taking 0. Here are the exponents because that's what I'm substituting it in for the exponent. So if I have 1/2, what this means is to the 0th power. I'm going to write my work here. Anything to the 0th power is what? It's 1, right? Okay. Now I'm going to take 1/2 because remember I'm taking 1/2 to all these exponents and I'm computing them here. If I take 1/2 to the first power, well, anything to the first power is itself. So I get to just hold on to 1/2. I can also turn that into 0.5. It's always nice to have both. Now here I'm going to take 1/2 to the second power. Now if I take 1/2 to the second power, it also means 1/2 times 1/2. And I know that 1/2 times 1/2 is 1/4. So it's getting smaller. Okay. So I think that is starting to show me some kind of pattern here. I'm going to now go to my negative. So again, sometimes those negative exponents can be a little bit tricky, but it just takes a little practice. So what this means is I'm taking 1/2, because remember all of these, right, are 1/2, because I get it from here. And I'm going to stick that to the negative exponent. Well, what this means is I'm taking actually the reciprocal, if you think about it, right? This becomes 2 to the first power. Whoa, isn't that cool? Anything to the first power is what? Is the actual number. So this 2 to the first power is just 2. Now I'm taking 1/2 to the negative second power. And again, just like this one here, this becomes 2 to the second power. And that ends up resulting in a y of 4. So again, here are the outputs. So these are basically, here's the outputs, these are inputs, and these become ordered pairs, right? Well, now that we have ordered pairs, I can go ahead and graph these. So let's go for it. Okay, so I'm just gonna put a star there because I really like starting with my 0 for x, because that's gonna give me my y-intercept. So if I go over to my graph here, right, I'm gonna go here, but then I'm gonna go up to 1. That's my first point that I'm plotting here. So maybe if I go up a little bit, that's better. Okay, so now I'm going to go, let's go into the positive territory because I'm feeling positive right now. If I plot this ordered pair, so it's basically 1 and then 1/2. I'm going to plot this one now. I have 2, so I'm going to go over 2 and up 1/4. So it's starting to get this kind of cool, very relaxed slope right here, right? You might be able to predict what comes next, but in essence, this is never going to get to 0, but it's going to get really, really small, very close to the x-axis if you think about it. Okay, so now I have some negative. I'm going to go to the negative territory now. So if I zoom out a little bit, I have -1, and I'm going to go up 2. So -1 here, I'm going to go up 2. 1, 2. I'm going to plot my point there. I'm now going to go to -2. So 1, 2, and up 4. 1, 2, 3, 4. Okay. So hopefully you see, and if I zoom in on this a little, you can see that it's not a linear, but it has a little nice little curve here. So what I like to do here, and I'm going to go back here for a second. If I added a -3 here, just because I wanted to see kind of how drastically this is going to go up, because I want to plot it one more point, you might be able to predict that this has a relationship between these two values, like basically 1 squared, right? 1 times 2. 2 squared is 4. Well, what's 4 squared? Well, it's going to be 8. So this, if I look at now, negative 3, 1, 2, 3, up 8, 1, 2, 3, 4, 5, 6, 7, 8, right? That's a pretty drastic jump. And now I can go ahead and do kind of this cool little curving. It looks kind of like a hockey stick or something like that, right? What I just did is I just graphed a exponential function, and I made it visual by doing it. So here's my work, here's my function table, and here's my graph. Now I have to characterize this. So first of all, is this growing? So as we go to the right, is it getting bigger? Well, it's not. It's actually dropping really fast. And if I look back to my b value, which is about half, right? That is less than 1. So this is decaying really fast. So that becomes decay. Now, if I think about the domain, I just picked all these numbers, right, for x. So I could really pick any real number and I could pick 17 here, right? And I could chug it through my machine here, and I could get some kind of output here. So really, if I think about it, my domain, or what I can put into my machine, is really all real numbers, if you think about it. There are other ways, more sophisticated ways to write this, but for now, I want you to wrap your head around that, okay? The range, if you remember the video we saw, the range is, well, what kind of outputs are we gonna have, right? Well, if I go back here, so again, the domain, or all the x's, right? I can pick any x I want, but the y's, I am kind of limited here, right? So this is all going to be over or larger than 0. It doesn't actually become 0, but the range is basically becoming, well, anything over 0. Because there's nothing down here. There's nothing negative down here. And it's only going to go like this and kind of settle into this line, the asymptote here, and then it's going to keep going drastically up. And we're going to go, if I kept going, right, really drastic. My y-intercept, well, that's the one I first started with. So the y-intercept, and I'm going to write it as an ordered pair. All right, it was just whatever 0, whenever my x is 0, then the y is the value there is the y-intercept. Then the asymptote is 0 because it's getting really close. It's that line that it's sitting on but not really touching. Okay, so that was a lot of work for one. We're going to keep going. I know it's going to be a long one, but that's okay because it's a Tuesday night and I have nothing better to do than watch Battlestar Galactica. So I'm just going to go, in interest of time, I'm going to choose this is like the golden 5 x values that you can choose for lots of function tables. The y's, okay, well, this is going to be a little trickier because we have, this is our b, right? If you think about it, that's our 5. So this is now becoming a subtraction problem. So this is still our b, but we're doing something else kind of wacky to this. So things are going to get a little wackadoo. If I have x is 0, so here's my little work column that I'm going to try to show. And I'm going to put some lines here just so it's clear as mud to see. So what this means is, here, I'm going to put this in, right? 3 to the 0th power minus 5. Well, what does that mean? Well, anything to the 0 power is what? 1, okay? So that equals 1 minus 5, okay? So it's 3 to 0 minus 5. It's 1 minus 5, which is -4. So I now have my first ordered pair, and I also have my y-intercept. Yay, that's pretty awesome. Now if I look, let's go to the next one. So now I have 3 to the 1st power minus 5. In fact, I could probably save a little time. I could do 3 to the 2nd power minus 5, and then you could actually see the pattern. 3 to the -1 minus 5, 3 to the -2 minus 5, and I could just solve them all at once like that. And again, here's where I'm doing my work. So I have 3 to the first power, which is 3. And I'm subtracting 5 from it. So 3 minus 5 is negative 2. I'm going to go ahead and put a star by my y-intercept. Now I have 3 to the second power. So 3 times 3 is 9 minus 5. 9 minus 5 is 4. So I have a positive value for y now. Interesting. If I go back here, I know that 3 to the negative 1, or the negative first power, is 1/3. Okay, minus 5. This gets a little tricky. A third minus 5 is actually going to be negative 4 and 2/3 if you think about it that way. Likewise, 3 to the negative second power is equal to 1 over 3 squared, which I can just write as 1/9 minus 5. 1/9 minus 5 is negative 4. And it's going to be a decimal. If I keep going up here, you might even notice something. That this is going to be lots of negative 4s, right? Is it ever going to be negative 5, though? That's an interesting question. Could that give us information about this? Maybe. Okay, so let's start. First of all, do you guys think this is growth? It is, because this is our b value, right? That's getting raised to that exponent. That is a whole number, and it is greater than 1. So I can go ahead and already decide that. Do I have my y-intercept? I think I decided, remember, because I picked it out here, so it was going to be negative 4. Okay, so our y-intercept is negative 4. Well, I should write it correctly, sorry. Like that. Okay. Okay, so now let's start graphing this stuff. I know it's a very long video, but let's start with 0 and negative 4. So I'm going to go to 0, right? And I'm going to go down 4. 1, 2, 3, 4. I have my first point. Okay, then I'm going to just kind of zoom up. Hopefully you can see this still. Then I'm going to go, I have 1, and I go down 2. Okay, so I just plotted my second point. Then I have 2, and I'm going to go up 4. Whoa. 1, 2, and then I'm going to go up 4. 1, 2, 3, 4. Whoa, that's like pretty steep drop off here, right? Kind of cool. And then I'm going to go into the negative land. So I have my 0, 4. And now I'm going to go, I have negative 1 and then negative 4 and like over a half, right? So I'm going to go negative 1. I'm going to go down 1, 2, 3, 4. And I'm going to go down like, again, a little bit more than a half. Okay. Then I have negative 2 and then I go to negative 4. So negative 2 and then I'm going to go negative 4, but then a little more. If I keep going, it's going to look something like this. It's going to just dance on this line. And if you think about it, 1, 2, 3, 4. This is really negative 5, if you think about it, negative 5 here. So guess what? That tells me that all of my values, my range has to be in this territory, right? I don't have anything down here. So the asymptote is, we write it y equals negative 5. That's where it sits. It hovers over that. My range is y is greater than negative 5 because nothing is over here. And my domain, well, again, I could put any numbers in my input, right? Any real numbers. I can't put imaginary numbers into that to get me some good outputs. Okay, so far it looks like I have 1 decay and 1 growth. What do you guys think? What's the third one going to be? Let's do it. Can you already tell? What's my b value? Oh, it's 2. I think you already know it's going to be growth. Okay, so we've got x, we've got y. I wonder if I can speed it up. I'm going to show my work over here. I'm going to try to make my straight lines as well as I can. I'm going to create an actual table here so it looks as neat as it can make it. I'm going to pick my go-to, my golden 5, I like to call them. Okay, and I'm going to show my work. So I have 2 to the x power here. So here I go. So I have 2 to the 0th plus 1. Anything to the 0 power is 1. So 1 plus 1 is 2. And I'm going to do what I did earlier, which is I'm just going to write all my work here first. So maybe you can see the pattern. 2 to the negative 1 plus 1, and 2 to the negative 2 plus 1. Okay, now I'm going to do a little work. Okay, well, this is an easy one, right? 2 squared plus 1 is 5. Right? 2 to the first power, well, that would be 2 plus 1. This is 3. Now, if I go here, I have 2 to the negative 1 power. So that equals 1/2, writing small, plus 1. Well, 1/2 plus 1 is simply 1.5. Now I have 2 to the negative 2nd power, which is actually 1/4. It's a good one to memorize, plus 1. So 1/4 plus 1 is simply 1 1/4, which I'm just going to write in decimal form now. Okay, so I've got some points. I got my 5 points. I'm going to start plotting this great line. Here is my y-intercept. I'm going to start with that. So I'm going to go zooming out here. I have 0, 2. Okay. I have 1, 3. So I'm going to go over 1, 1, 2, 3. I have 2, 2, up 5, 1, 2, 3, 4, 5. Okay, and I could keep going if I really wanted to, but I know this is going to go something like this, right? Let's go to the negative territory. Negative 1, then up 1.5 right here. Then I have negative 2, and up negative 1/4. So I'm just going to kind of like start going to this line, right? And I'm not going to go past. So I have a beautiful looking exponential growth here. It's a little different here because where it basically lies, right? So now let's analyze this. If I go over here. So I know this is a growth because I have a number, a b value that's greater than 1. My domain is all real numbers, right? I just chose the golden 5, but I could add any real numbers in there. The range or the output numbers, right? It's not every number in the whole universe. The range is anything that is over, really, 1, right? Anything that's above this line. Then we have our y-intercept. Well, that's where we started, right? Right there. So that's my coordinate for my y-intercept. And my asymptote, so where it sits and hovers and dances beautifully but just doesn't touch, is 1. So the y at 1 is where it sits. I hope this was helpful. This is kind of a lot. It takes a lot of work. Stick with it, and good luck. We're going to practice a lot of this. Bye.